So I just ran out of time, so I'm going to finish this from the last video. So this is A plus C using the the parallelogram rule. Okay. Sign law. If you look at the archive note from last year that's available through your online classroom, you should see a proof for the sign law. This is grade 10. You saw it again in grade 11. It should be review. Basically, the sine of an angle and its opposite side are all in proportion as you work your way around a triangle. Cosine law is basically Pythagorean theorem with an adjustment, if you like. And there's three versions of it for the three vertices. But there you are. Cosine law should be review. Magnitude and direction for vector sums. Your note, I believe, is corrected for this. This has to do with what vector they're actually dealing with. You see how they have a +2, and cosine law always has a minus. Well, when it's minus, it can't be theta. There's a big deal here. Theta is defined as the angle between two vectors when they are tail to tail. And if you see that, that's actually not part of the triangle where the resultant is. Theta is out here. And if you want to use the minus, then we'll call it gamma, and we'll put a gamma here. I would do that. Just be aware that the theta you're given is not inside the triangle that, has the resultant as part of the sum. So this is cosine law, both versions. I would use it the way we learned it in grade 10 and 11. Just realize that this angle that we're actually using is the supplement of theta, the angle between the two. Okay, there we go. And now we're going to use it, I believe. Oh, we're going to analyze some special cases before we get to example 5. So analyze the following specific cases of the addition of two vectors. So we're going to add vector A. Well, let's see. Vector A and vector B. If you look at this, the angle between vector A and B is 0 degrees, right? That's what they're saying. So they're parallel. And so the resultant, A plus B, is really simple. It's right here. Well, what they're trying to say is you don't have to use cosine law here. I think you can just take, to get the resultant, the magnitude of the resultant, you take vector A and add the magnitude of vector B, and that's all that's to it. It's really straightforward. And the next one, they want you to analyze what's going on when the angle between the two vectors is 90 degrees. So let's say we have vector A and vector B, and I'm adding them tip to tail. They don't have to be the same magnitude. Theta is out here, and that's 90. How do you get the angle of the resultant, the magnitude of the resultant? Well, how would you get it? Well, it's a 90-degree triangle, so the magnitude of A plus B is simply the square root. Magnitude of A squared plus the magnitude of B squared. And the angle for, let's say, alpha, tan alpha, simply the magnitude of B, magnitude of A, SOHCAHTOA, tan, opposite over adjacent. There we go. And for C, angle is 90 degrees. So let's say you have A here and not 90 degrees, 180 degrees, pi degrees, right? B here. This is A plus B. So the magnitude of A plus B would simply be the magnitude of A minus the magnitude of B. And that's really all that's to it. Don't have time to do example 5 without running over, so I'll start that in the next video.